Hi, my name is Stijn van Verdegem and I'm a Senior Technical Product Manager with the VMware Network and Security Business Unit. This is a short demo of the application and protocol identification for Layer 7 functionality that is part of the context-aware feature set in NSX 6.4. The context-aware architecture in NSX 6.4 augments microsegmentation by enabling customers to filter on other contexts and attributes beyond the traditional 5-tuple or L3 and L4. Specifically, with regards to application context, in NSX 6.4, users can apply microsegmentation policies independent of the port an application is running on by using built-in service objects that are based on the Layer 7 fingerprint of an application. Or they can enforce an application to only run on a specific port. For instance, users can choose to only allow HTTPS to use TLS 1.2 and run on TCP port 8080. Our focus is on applications that are typically found in the data center infrastructure, such as Active Directory or DNS, and applications commonly used in enterprise applications, such as MySQL and HTTPS. Benefits of the app and protocol identification feature are enhanced visibility into the east-west application flows in the data center, as we can now identify the L7 application in addition to the port the traffic is running on. Beyond visibility, rules based on L7 or a combination of L7 and port further reduce the attack surface by only allowing traffic matching a predefined application fingerprint, allowing security teams to force the application to use a particular port or ensure only desired applications can run on a particular port or across any port. And as I had mentioned earlier, it also allows customers to block vulnerable versions of applications. Now let me start with the demo. In this demo, I'll show a couple of basic distributed firewall rules that are using Layer 7-based service objects to microsegment an application. I've created two firewall sections. The first one I've called Application Access, and I've added a few rules that allow access into the application, such as HTTPS to the web tier, as well as SSH. When we look at one of these service objects, we can see that we are matching on the HTTPS TLS version 1.2 application fingerprint or the SSH fingerprint for the second rule. The second section microsegments the application itself and only allows flows in between application tiers that are required for the application to function, such as HTTPS from the web tier to the app tier and HTTP from the app tier to the database tier. And now let's confirm that our Layer 7-based microsegmentation is actually working. But before we do that, let me have a look at all the different applications that we support for Layer 7 in the 6.4 release. So we can go into our list of applications here, or list of services, filter on app, because all of the built-in service objects start with app for Layer 7. And here we can see protocols like HTTPS, IMAP, LDAP, NFS, MySQL, and a lot more built-in applications that we can detect at Layer 7. So now let's have a look at live flow monitoring and confirm that we can detect those flows based on Layer 7 as well. Let's refresh our application to get some flows going. And here we can see the live traffic coming in, and you can see that we've correctly identified the traffic here as being TLS version 1.2. Now let's go back to the firewall rule table and let's change our policy. In this case, we have a rule here that allows SSH into the web tier, and this is simply based on the SSH fingerprint of the application. So this will allow SSH across any port. So let's confirm this by attempting to access the application on port 22. And as you can see here, this is working fine. We're able to log into the SSH server. Now let's change this rule, and instead of using the built-in app SSH service, let's create a new service object. And with this service object, we want to be able to allow SSH based on the application fingerprint, but only across port TCP 2222. So we set this to Layer 7 as a service type, select SSH as the application ID, TCP as a protocol, and 2022 here as a destination port. So now that we've created the new service object, I can go back to the firewall rule table and remove the existing app SSH service object here and instead replace it with the one that we've created, which is app SSH on TCP 2222. So we can filter in our list on app SSH and select the service that we've just created. click OK. Now we publish the changes here to the firewall rule table. And now let's try to SSH into our application again. And as you can see, this time the SSH connection is not being established. Now, when we go back to live flow monitoring, we can see that the traffic was correctly identified as SSH, but it was being blocked this time because it's running on port 22, and we're only allowing SSH on port 2022. And that concludes the demo for Layer 7 based application and protocol identification in NSX 6.4.